Have you ever wondered if the Earth itself has a reset button? What if the greatest threat to our civilization is also a potential, albeit terrifying, climate regulator? Today, we're diving deep beneath the Earth's crust to explore the world of supervolcanoes. Are they silent climate engineers or the ultimate doomsday triggers? First, what exactly is a supervolcano? Forget the classic cone-shaped mountains you see in pictures. A supervolcano is a volcano capable of an eruption of magnitude 8 on the Volcano Explosivity Index, or V. This isn't just a big eruption. It's an event that can eject more than 1,000 cubic kilometers of material. To put that in perspective, that's enough rock and ash to bury an entire country. These aren't mountains. They are often vast depressions in the ground called calderas, like the one stretching across Yellowstone National Park. They are slumbering giants, with massive magma chambers bubbling just a few miles beneath our feet. The pressure builds over hundreds of thousands of years, waiting for the moment it all blows. Let's first confront the terrifying side of the coin, the doomsday trigger. When a supervolcano erupts, the immediate devastation is almost unimaginable. Imagine an explosion so powerful it dwarfs the most destructive nuclear weapons ever created. The blast would instantly obliterate everything within a radius of hundreds of kilometers. A pyroclastic flow, a superheated cloud of gas, ash, and rock would race across the landscape at supersonic speeds, incinerating everything in its path. Take the Toba eruption in Indonesia, about 74,000 years ago. It was one of the largest known eruptions in Earth's history. It created a caldera that is now the largest volcanic lake in the world. The sheer volume of material ejected was staggering. Scientists believe this event was so catastrophic it may have pushed early humanity to the brink of extinction, creating a population bottleneck from which we barely recovered. Then there's Yellowstone, perhaps the most famous Its last major eruption, 640,000 years ago, was about 1,000 times more powerful than the 1980 eruption of Mount St. Helens. If Yellowstone were to erupt today, the consequences would be global. A thick layer of volcanic ash would blanket most of North America, collapsing buildings, contaminating water supplies, and causing widespread crop failure. The ash, fine as glass shards, would destroy jet engines, grounding air travel worldwide and crippling global trade. The immediate death toll would be immense, but the long-term effects would be even more horrifying. The world's breadbasket in the American Midwest would become a barren wasteland for years, leading to global famine. It's a true doomsday scenario. A world plunged into chaos by the planet's own raw power. But there's another, more complex side to this story. Could these apocalyptic events also act as a form of extreme climate engineering? This brings us to the concept of a volcanic winter. When a supervolcano erupts, it doesn't just spew ash and rock. It injects massive quantities of sulfur dioxide gas high into the stratosphere, far above the clouds. Up there, the sulfur dioxide reacts with water vapor to form tiny sulfate aerosol particles. These particles are incredibly reflective. Instead of letting sunlight pass through to warm the Earth's surface, they reflect it back into space. This creates a global cooling effect. The sky wouldn't necessarily be dark, but a hazy whitish veil would hang over the planet for years. Think of it as a planetary sunshade, inadvertently deployed by the Earth itself. Following the Toba eruption, for instance, some climate models suggest that global temperatures may have plummeted by as much as 3 to 5 degrees Celsius, with some regions experiencing even more drastic cooling. This volcanic winter could have lasted for several years, followed by a decade or more of a generally cooler planet. For a world grappling with rising temperatures, this might sound, paradoxically, like a solution. The planet essentially performs a hard reboot on its climate system. Historically, we've seen smaller-scale versions of this. The 1815 eruption of Mount Tambora in Indonesia, the largest in recorded history, led to 1816 being known as the year without a summer. Snow fell in June in New England, crops failed across Europe and North America, and widespread famine ensued. It was a V7 eruption, powerful, but just a fraction of a supereruption's potential. Imagine that effect amplified 10 or 100 times over. So, while the immediate aftermath is destructive, the long-term cooling effect is a scientifically recognized phenomenon. It's a brutal, chaotic form of geoengineering, but it highlights the immense and complex influence these geological events have on our entire planet's climate. However, the story doesn't end there. Modern science, with its advanced tools and computer models, is painting an even more nuanced picture. The idea of a full-blown ice age triggered by a supervolcano is now being challenged. Recent research, including studies from NASA, suggests the cooling might not be as extreme or as long-lasting as previously thought. Why? The models are becoming more sophisticated. They now account for the complex ways different gases and particles interact in the atmosphere. For example, the same sulfur dioxide that causes cooling by blocking sunlight also has a secondary effect. When it forms aerosols, these particles can absorb thermal radiation coming from the Earth's surface. This can lead to a warming of the stratosphere, which can alter atmospheric circulation patterns in unpredictable ways. Furthermore, a supereruption also releases vast quantities of water vapor and carbon dioxide, both powerful greenhouse gases. While the initial cooling from the sulfur aerosols would dominate, the long-term warming effects of these other gases could eventually counteract it. So, after a few years of dramatic cooling, the planet might actually experience a period of warming. Scientists are also considering the size and distribution of the ash particles. Earlier models might have oversimplified this. The exact composition and height of the eruption column can drastically change the climate outcome. It's a delicate and chaotic balance of competing effects. So, instead of a simple switch from a warm world to a frozen one, the reality might be a period of extreme climate volatility, wild temperature swings, altered rainfall patterns, and general instability. The idea of a supervolcano being a clean, albeit terrifying, solution to global warming is likely to simple. It wouldn't just turn down the thermostat. It would break the entire climate control system. So, where does this leave us? Supervolcanoes are the ultimate paradox of nature. They are, without question, one of the most destructive forces on our planet, capable of triggering a doomsday scenario that would threaten the very fabric of human civilization. The immediate blast, the continent covering ash, the global famine, it's the stuff of nightmares, and it's a very real, albeit low probability, threat. At the same time, their potential to radically alter the global climate is undeniable. They are unwilling climate engineers, forcing a rapid global experiment with devastating side effects. But as we've seen, the outcome isn't a simple deep freeze. It's a complex and chaotic reshuffling of the Earth's climate system, with effects that we are only just beginning to fully understand through advanced computer modeling. The cooling might be less severe than we thought, and the long-term consequences could be even more unpredictable. The dual nature of supervolcanoes forces us to confront our own vulnerability. We live on a dynamic and powerful planet that operates on timescales far beyond our own. The question is not if another supereruption will happen, but when. And this leads to the ultimate closing thought. Knowing what we know now about their immense destructive power and their chaotic influence on climate, how prepared are we as a global community for the day one of these sleeping giants decides to wake up? Thanks for watching. If you found this journey into the heart of our planet fascinating, don't forget to like, subscribe, and hit that notification bell for more deep dives into the science that shapes our world. See you next time.